All right, let's take a look at this triangle. So now we have the 45, 45, 90. So the thing about this triangle is that if this is 45 and this is 45, it's an isosceles triangle, and the sides opposite them are the same. So that's why this one is S, and this one is also S. And then this would be S radical 2. So now if you have a 45, 45, 90, because this is 45 and that's 90, then this other side has been, other angle has been 45 also, except it has to be 180. So if they told you that this side, for example, is 7, then this side is also 7. Right, and that again means that 7 is S. And this side, which is S radical 2, would really be 7 radical 2, because we found out that this side was 7. Do an easy one, or easier. Let's say this is 5 radical 2. Again, 45, 45, 90. So this is supposed to be S rad 2. So really we found that S is 5. So this side is supposed to be S is really 5. So it's supposed to be S is really 5. Okay, now let's do a difficult one that they could give us. And these could all be parts of a larger one. It doesn't have to just be find the missing sides. It could be like you have to find the sides and find the area or something like that. But let's say that they gave us this 45, 45, 90 triangle, and it told us this side was 8. All right, so now it's a little more difficult. Now what does S equal? Well, this 8 is supposed to match up with S radical 2. So to solve for S, we have to divide both sides by radical 2. Okay, we want to rationalize this. Like we don't want a radical 2 in the denominator. So something we could do is multiply the numerator and denominator by that radical. So 8 rad 2 is 8 radical 2. Radical 2 times radical 2 is radical 4, which is just 2. You can reduce because you do 8 divided by 2 is 4. So we have 4 radical 2. So that means that S is 4 radical 2. And both of these sides are S. So both of these sides would be 4 radical 2.
You can excel with Cadell.